computer. So now we're starting the Zoom Tuesday, 6 p.m., April 21st. And we're going to talk about the test, which is on Thursday. The window for the exam starts Thursday night from 7 to 11. You're going to have 2 hours to complete the exam. But if you start after 9 p.m., you will not have 2 hours to complete it. If you start at 10, you've only got an hour. If you forget about it, start at 10:30, you've only got a half an hour. Because the exam closes at 11 p.m., whether you're done or not. A question that came up a while back, which was a good one, you are able to go back and forth between the problems, between the questions. Okay, so once you get an answer, it doesn't lock you in. You can go back and forth. They are all scrambled, and no test grades and no answers will be generated, or you won't be able to see them until after 11 p.m., until after the exam closes. So I guess I would, the advice I would have is have your units quizzes out, have your homeworks. There's a boatload of reaction questions. There's a good number of symmetry for the exam. So anytime you see symmetry, just remember that, whether calculating a reaction or let me just let somebody in. Either calculating a reaction or doing some sort of structure analysis. So I thought this was a good example to show you. It has the original beam here. I'm not going to go through doing the reactions, but if you want to work, that would be a good one to work on as a review for the test. So you can get R1 and R2. Okay. The one thing, because it is a take-home, it's still multiple choice true false. So you will not be generating a shear moment diagram. You'll be analyzing them. So I would give you a shear moment diagram, and I would say, well, what is the VAT? Let me zoom in this little bugger. If I can get this out of the way here. So let's take this shear diagram. Now, what we're doing is, again, through the analysis, I could say, what's the value of the shear diagram here? Well, it makes sense that when the shear starts at 0, it's going to immediately drop down 8,000 pounds. And then over the next 4 feet, it's going to drop at a rate of 220 pounds because that's the beam weight. See, I broke it up into 5 zones of the span, and they are in between significant points. This first zone, zone 1, is between the end of the beam and the reaction. Zone 2 is the start and finish of a partial linear load, which is added to beam weight. So here you can see total drop in forces is 220 plus 400. Okay. And if any of you hear from anybody, you've got to type in your whole name to join the Zoom. So I could ask you a question that, what is the value of the shear 2 feet away from the left end of the beam? In other words, what's the value of the shear here? Right? Now, over 4 feet, it's going to drop 4 feet times 220 PLF. So over 2 feet, it's going to drop 2 times 220 pounds per foot for a total of 440. Because it's beam weight, it's acting down. That means that the shear is actually going to increase in the negative direction another 440. So the answer of the shear right at this point is 2 feet times 220, which is 440, which is negative. So it's negative 8440. So those are the type of questions that I'm going to ask you. You know, I could ask you the value of this point. Well, if you know the value here, right? If you know the value of the shear at this point, all you got to do is take the reaction and add the reaction to that negative 8800. And that's going to give you a positive 6367.7. So what you want to do is study this as a review for the test and learn how to generate any one of these values at the significant points, both on the shear diagram and on the moment diagram. And I've laid it out for you here in ancient Babylonian Sanskrit that the value of the moment curve here is the area 1 value. This is area 1 plus area 2. Okay, so area 1 was negative 33,760 foot-pounds. Makes sense because area 1 is negative, but area 2 is positive. So whatever that value is of area 2, you're going to add it to the previous value of the moment curve. Now, one thing you will see, I'll tell you right now, it's going to be on the test, is how do you find this distance from either the left or the right significant point to where the shear crosses the 0 line. And that's the slope. I'll tell you right now, just have an example in front of you. While you're taking the test, you can look at it. And that'll remind you that the run, let's see, slope equals rise over run. So run is equal to the rise divided by the slope. And the rise is, I'm going from 2647.7 pounds. I'm dropping down to 0, so that's my rise. I'm decreasing, so it's going to be that number divided by the slope, which is 220. Which is 220 pounds per foot. Okay, 220 pounds per foot. So figure that out. Here, you can figure out this distance, and that is 652.3. It's negative, but it's going to go from minus 652.3 up to 0. So it's minus 652.3 divided by that same slope of 220 pounds per foot. So I'm just going to fire up that number. So 652.3 divided by 220 is around 3 feet. So that's how you study for the shear moment diagrams. Okay. Now, when you're doing a test, and I ask you for a shear, this is where you want to be able to work the shear loading in your calculator without clearing it, okay? Without clearing it. So if you looked at your calculator, tell you what, I'll go to the camera and I'll actually write those down. Before I do that, don't forget, if I ask you for a value of the shear curve here, you can go from the right end to, you know, we know that we ended at 0. At this point, we know it's 1500 because we had to drop, right? As we were moving left to right, other than the reactions, our downward loads are making that shear drop. So that 1500 makes sense because then I drop that concentrated load of 1500 to get to 0. So you can work backwards. This slope is still what? It's still 220 pounds per foot. If I'm moving left to right, it's decreasing. But if I'm moving right to left, it's increasing at 220 pounds per foot. So you could say that 1500 plus in parentheses, that's a 4-foot span times 220. That gives me my 2380. So you can move right to left using these slopes. Why is this slope so steep? Because it's got a partial linear load plus beam weight. Okay, plus beam.
You're gonna put a cantilever on the test?
You'll find out on Thursday.
All right.
Jesus, I didn't get a laugh out of that one. Sorry about that. Oh, I got one for you there. Whoops, where'd it go? Oh. Can you hear that?
No.
No.
No. I always get the volume messed up. Damn it. And Haggard all ready for you. So,
So are we allowed to take the test earlier than Thursday, or is Thursday the only day they're on the
oh, 7 to 11. No, I don't do that. You know, I'm not a big fan of online tests, but it is what it is. So, no. No. So if you are, do you want me to go through this shear diagram on the board? With the calculator, if you've got that in front of you, is that something you want to, would that help in the review? Jesus, is anybody alive out there?
Yeah, that would help.
Okay, jeez. God, it's just like being in the pit asking 60 people a question. They all stare at you. You're staring at me through the computer. Okay, so I'm going to go to, I'm still only seeing, oh, this guy I can let in. Again, if any of your buddies text you that they can't get in, they have to type in both their names. First and last. So I'm going to go to the camera. Not a big fan of it, but I'm going to. And then, oh, I got to hit the share screen. So now I'll run these numbers. So get that shear moment diagram in front of you. I'm not going to put it up here. I'm just going to run the numbers. Right? Get that one right in front of you. Okay. What do I do with that? So the shear always starts at what?
0.
0. Okay. So the first thing I'm going to do is I see that I'm dropping 8,000 pounds. So that is going to be the value of the shear at the left end of the beam. It's both 0 and minus 8,000. I suppose I could draw it real quick. Let me do that. I should have done this before. Damn it. Uh, 1,500. So I'm not going to draw the shear curve. I'm just going to talk about the loads. Oh, actually, no. Okay. Draw those light lines down. Okay. And then there's the moment curve. So let's do the calcs also. So it was 0 minus 8,000 pounds. So on my shear curve, I went from 0 minus 8,000. Leaving that in the calculator. Actually, I'll try that also. So 0 minus 8,000 equals minus 8,000. The next, it's 4 feet. Minus 4 feet. Actually, I should do this down here. I'm not going to do the moment curve, so I'll do it right here. Sorry about this. So 0 minus 8,000. Okay. Minus, in parentheses, 4 feet times 220 pounds per foot. So from there, that's the value of the shear curve there. So I go minus, left parentheses, 4 times 220. Left parentheses is going to drop 880 minus 8,800. Okay. So leave that right in your calculator. Now what do I do? Bueller, anybody?
Now you have R1 going up, right? The
Right.
cantilever.
Right. So I take whatever that value was, I leave that right in my calculator, and I'm going to add, if I can find the damn plus button, 15,247.7, and that's the value of the shear curve right here. So that's 67.7 pounds, right? So I added R1, which was 15,247, okay? And that's going to give me that value right there. Now this was 400 PLF, but also 220. So it's 620. And that was how many feet right there? 6 feet. So I'm going to drop from that value. Everything's bass backwards here. I'm going to drop left parentheses 6 feet. Times 620. Right parentheses equals. So that value is going to be 2647.7. Leave that right in your calculator. So we'll do another color. Right? Do you hear that noise? Okay, so that's 2647.7 pounds. Hollywood hasn't called yet after all my Zooms. I'm quite upset. So then I'm going to analyze a 15-foot section of the span. This is 15 feet right here. And I'm back to 220 PLF. Hey, a lot of units on those on the test, right? You know, what's a little bit off to the side here? What is moment of inertia divided by section modulus? That's inches to the fourth divided by inches to the third. Survey says it's inches. So I would have that that units handout that I gave you on day one, I'd have that right next to me. Okay? So that number, I'm going to drop minus left parentheses 15 times 220 right parentheses equals. And it's minus 652.3. This is not the scale. Minus 652.3 pounds. Okay. And at some point, we got to figure that out. We talked about that earlier. Okay. So now this one is 800 PLF. It's 220 beam weight. So that's 1,020 PLF over how much of that? That is a 5-foot section of the span. So I'm going to drop minus left parentheses 1,020 times 5 right parentheses equals 52.3 negative. So again, try this. If you're not doing it now, you should be. At least try it before the test. Then what do I have to do? I got R2. I forgot to write it down here. Sorry about that. So I'm going to add R2 is 8,132.3. 8,132.3. So the value of the curve there is 2380. In other words, I go straight up. 2380 pounds. This last little part is 4 feet. I'm just at 220 PLF. So I'm going to say, I'm going to drop left parentheses 4 feet times 220. I'm going to drop 880, but it's going to give me a value of 1,500. And lo and behold, that's what I got. And that's going to drop me back to 0. So we had area 1, which is negative, area 2, area 3, area 4. These two are triangles. Everything else, what's this? This is area 5, area 6. They're all trapezoids. So the area for any one of these is the average of the shears times the distance. And that's how you calculate the areas. And you have all the calcs for the areas on your handout. Okay? So practice that. And there's a fair number of questions on that. Okay? Any questions on the shear? I want to go over a couple more things. So I'm going to get away from this just for a second. So now I'm going to switch screen. Where the hell's the switch screen?
So you were only showing us how to calculate different parts.
Yeah, because it's multiple choice true false, you're not going to generate an entire shear moment diagram. We're going to have you analyze it. You're going to have to find values. Okay? You're going to have to find values. One other thing that you want to look at is, and I don't have it on a PDF. I just thought of it. I went over a load trace showing just a simple frame. And I asked you to look at, tributary widths and then calculate reactions. There was a problem on that for beams when you did the reactions 6 through 10 plus a load trace. Now, unfortunately, we have those pieces of paper. You don't have them. But you do have a homework assignment that that was the same type of problem. Okay, let me just admit a couple of people. And those of you who just came in, sorry about that you waited so long. So as I'm chatting, if I can find one of those, I will. But it's a basic steel frame, two-dimensional, and I know I gave you a homework assignment for it. It dealt with tributary widths and so on. Now, another thing that you're going to see is JN's. Let me move this back a little bit. This is JN's chapter 5. And let me go back to my list. So JN's chapter 5, you have that on Vanco. But it's the last 2 pages that, I mean, you're going to see some basic pressure and stress calcs, but you're going to see some stress and strain questions on the test. Okay? I don't know if it's a marshmallow, but it might be. Now, one thing you're also going to see on the test is the back page of this. This is page 64. So we went over this in depth. We did our very, very technical test on a marshmallow to see what its modulus of elasticity is, which is a measure of a material stiffness versus the moment of inertia, which is the shape stiffness. Okay, but on the next page after this, I did put a question on the test using this formula. In other words, how does temperature affect stress? So there will be a change in length based on a thermal coefficient of expansion, varies with different materials, the change in temperature, and the original length. So you might want to study that one, if you know what I mean. Okay, and JN goes through and does an example. Okay, so take a look at those 2 pages, and that'll help you for the test as well. Just going through my, yeah, that's the ticket. Maybe I can find real quick. Statics, where the hell is it here? Beams 6 through 10. I could have sworn I saw it. Oh, yeah, remember this? I gave you, we went over this in lecture. So
you might want to look for all your examples on that and understand how to do those. Okay, I think that'll be helpful. And also, if you're taking structural theory, Mr. H does this a lot. So take a little screenshot of that and take a look at it. Go back and try to figure out how we got all the answers. Remember, we talked about tributary widths and so on. Okay. This is the answer key for the, and this is posted on Banco. This is the answer key for problem 8-1. Okay. And I don't think there's a, this will be on the final, this fixed end reaction. I don't think it's on this test. But, you know, shear moment diagrams are. And then the stress calcs, very basic. A basic mistake was that this is in foot pounds, M max. It's got to be in inch pounds. So you had to do the conversion. So always check my numbers. See if you're close. See if you do find a mistake, definitely let me know. Here's the bending stress calcs for the deck, for the deck joist, okay? And, you know, we talked about page 278, which were different types of materials have different allowable stresses. And then when you go into the bending stress, M over S, some of you did MC over I, but M over S is easier. And for a rectangular cross-sectional shape, if you look at that 2x10, 9 1/4 by, I got to go back to my photon torpedo here, 9 1/4 by 1.5 inches. And it's BH squared over 6. I think that's on page 2 of the units handout. So again, make sure you have that units handout in front of you. Okay. Oh, units quiz 11 will open tomorrow morning at 8 a.m. and it will close Thursday night at 11:59 p.m. So I would advise you to take that right away tomorrow. Excuse me. And that'll be a good review for the exam. Okay. So.
I have a question.
Yep.
So I was going to ask this last lecture, but I forgot to. Why is it divided by 6? So I don't understand. I understand why it's base times height, but I don't know why it's divided by 6.
Well, it's base height squared divided by 6. And what's your major?
Architecture.
You're going to learn that next semester.
Okay. For
this semester, I do the easy route. Just remember it's BH squared over 6. And don't forget AutoCAD. AutoCAD gives you shape properties, right? If you had a shape that you showed in AutoCAD, you can get the cross-sectional area. It also gives you the moment of inertia, the section modulus. Another one is called radius of gyration. Pass the word. You might want to remember that one. Radius of gyration. That is on the units handout, I believe page 2, and it deals with buckling in columns. So the radius of gyration. Hopefully everybody will watch this sterling lecture of mine on YouTube, along with 4 million hits. The radius of.
Are you gonna leave? I'm sorry for interrupting. So are you gonna leave the videos in YouTube?
I'm right on a roll here. Just a minute. The radius of gyration deals with column buckling. You might want to remember that one. Okay, and if you ask me that whether or not I'm going to put this on YouTube, there's a big tear in both of my eyes because one of the freshmen asked that same question last night. And I've been doing this.
No, I'm not asking. I'm asking if you're gonna leave those videos on YouTube.
Oh, well, my tears just went away. Thank you. But boy, I did cry last night when after 4 weeks, he asked me, hey, do you put this on YouTube? And you've been proud of me. I kept my temper. I didn't swear. I wanted to. So anyway, sure, I'll leave them on for, in other words, when you're in structural theory.
Yes, that's what I mean.
Yep, I'll leave them on. Sure. Yeah.
Thank you.
I might start doing them for other classes, especially when we get in, this is off subject a little bit, but we do some surveying software. And I know Mr. V has done some great videos too. So this is one of the good things coming out of all this crap going on. And as always, I hope you and your families and friends are all healthy for sure. So that's kind of what I had as a review. I hope this helped. I've sent out emails, or I sent out the email through Vanco. There are a few of you, and you're probably not in this audience right now, but you're not doing your homework. So if you have any friends who you know are not doing their homework, you might want to remind them to start doing the homework, and also to study for the test, and actually even to take the damn test. Again, Thursday, 4-hour window during which you have 2 hours. Once you start, 2 hours. Okay. And just
With the amount of questions, sorry to interrupt. With the amount of questions on the test, like, will the 2 hours be like no problem to finish?
well, I'm going to grill you a little bit. The test is how many hours? You get 2, but I designed it for how many?
4
1.
or 1, right?
Good Lord, I'm not a communist. Whoop, shouldn't have said that. Now, we'll see if YouTube gets after me for that one. They shouldn't. No, I mean, I'm going to try to make it fair, folks. It's an hour test. That was my pacemaker just went off. It's an hour test. You get 2 hours to do it within a 4-hour window. I know everybody has unusual schedules, and that's why I picked a night class. I didn't do it to be annoying. I just found that some of you are working and during the day, and so I think this will benefit you. Just make sure you have everything in front of you. The notes that you've made, and some of the types of problems that you know are going to be on there, especially that units handout. God, that's key. That is key. So, any other questions? Hopefully I have been recording, so that's good. I only didn't swear, just said communist once. So I got that going for me. Any other questions? And we'll have a Zoom Friday at 11. I think it's just going to be on an easy lab thing. If you make it, great. If you don't, again, I'll post it to YouTube, and maybe some really easy calcs that I'll make do Monday night. Give you a couple days to do them, but they'll be pretty easy. Okay. All righty then. Like I said, I miss you guys. I wish we were doing this in person, but and God, don't tell anybody that I said something nice. I got my reputation to uphold. So without further ado, I'm going to stop recording unless there's any final questions. Dead silence.